Hello everyone, welcome. Today we're going to resolve daily LeetCode problem number 1534, count good triplets. So in this problem we are given an integer r and three integers a, b, and c. And we need to find the number of good triplets. A triplet ri, rj, rk is good if the following conditions are true. 0 less equal I less than j less than k, and k less than array length. Now we have array I minus array j, their absolute value less than equal a, array j minus array k, absolute value minus equal less equal to b, array I minus array k in absolute value less than equal to c. So here we explain where x determines the absolute value of x. So we already know that we will need to use math absolute. And we return the number of good triplets. So here we have a few examples of array, of our integer ABC, and output. I would approach this as a good story. Once upon a time, in Numberland, there was a curious little robot named TripBot. TripBot had a list of favorite numbers called R, and he wanted to go on trip with his friends from the list, but not just any three. They had to get along well, so TripBot made three simple friendship rules. The first friend must come before the second, and the second must come before the third in the list. The first and second friends can't be too different. The difference must be less than or equal to A. The second and third must also be not too different. Their difference must be less than or equal to B. And finally, the first and third should be also close enough. Their difference must be less than or equal to C. TripBot wants to know how many such group of three friends can he choose. We, as clever coders, are here to help TripBot count all the good triplets in the list that satisfy this condition. So, we are given input, and input we have array, and we have three integers a, b, c. As we already understand, we should return a number. So our output is count of good triplet. And we have conditions. We have one condition, we can just copy paste this condition because generally we will follow them. Comment, line up at our condition. The first condition already satisfied in constraints, so we mark this. In constraint. So already satisfied, and we will need to work on the next three condition. We can make it easily as recommended in hints. So we can use brute force and loop through all count of them. So we will use algorithm brute force. It will be close to enumerate. It will close to enumeration, and for For data structures, we will use array, we use counter, and finally we use math apps. Count the value. And here we can have few examples to understand better how math apps works. For example, return, let's start just math ABC. We have 3 minus, for example, 1. Our output will be +4. And for example, if we have math ABC 3 minus 1, output would be +2. Not exactly plus, but it wouldn't be negative, to be positive. It's a little to better understand how exactly it works. Alright, so we have already understood what we should do, what our output and what our input, and the general idea how we resolve this, and structures that we will use to resolve this. So let's start coding. First we will start with our count. Count will be starting from 0. Second, we will start with the length of our array, because we will use it 3 times for nested loop to check all 3 conditions. So we will use for and I equals 0. Here we will make slightly modification, because we will subtract 2 from array length. Although it wouldn't change time complexity from big of n squared 3, it will help because we wouldn't loop the conditions that are not satisfied. For example, if we will move 3 elements at a time, we start with 3, 0, 1, then we move 0, 0, 1, then we move from 1 to 9, then we move from 1, 9, 7, and as you understand, if we try to move I to position 9, it wouldn't be done, because we will have only I, we have J, and our K is outer boundary. That's why we should have 2 elements less, so it's not necessary. The same will be for K, but for J. For J, we will minus 1 element, because K should be at the position of 9, and K will loop through all array, because it's the last element. Little trick. Then for and J equal I plus 1, then J will be less than length of array minus 1, and I again forgot to increment them, increment I, increment J. Here's another trick we can think about. It's quite easy to understand that we have 3 conditions, and only if 3 conditions are the same, we should return number, count a good triplet. But if the first condition isn't true, we can skip checking the second and third. So we can do this by using continue function. Add to be precise, we use math abstract. We use first array I, then array K, J, and if the absolute value is bigger than I, then not following the condition equal or less, then we can just skip it and move so on, saving us some time complexity by not checking the second and third condition. Now let's move to K. It will equal J plus 1. K will loop through the entire array. K increment. The same with skipping can be done for the second condition. So we have math abstract. We have array. We will start with J, array minus K, and if their absolute value is bigger than B, we will just continue. And lastly, math apps array first element I minus array K. Now the last condition is satisfied, so it will be less than equal C. Now we can increase our count by 1. So we finally found the element that we were looking for, and we will return our count. So let's run this code. Pretty good, and submit. And it's also pretty efficient. So the idea here that we use 3-nested loop to make sure we only count triplets where I less than j and j less than k. We add early exit by using continuous, so if the first condition untrue we exit, if the second condition untrue we exit, and only if the last condition true, which means the first two also true, then we increment count. It makes it more optimized brute force, but still time complexity will be quite big. Complexity big of n square. Yeah. And also let's implement the same code with Python and JavaScript. Yeah, why not? Here it will be slightly less and faster. So we have count, we will be equal 0, on our columns, we'll have n, which will be equal len, array, so slightly different, we change from array.length to just length. Then for loop we use a study bracket, we just in range. Here we will just provide n minus 2. Then for j in range, and here we provide I plus 1 and minus 1. Now again we have we already have I and j, so we can check the first condition. It's also be easy because we need to use only ABS instead of math ABS absolute value. Ri minus rk or d bigger than a, which means continue. So there's no need to check other. And lastly, for k in range of j plus 1 and n, and here we have the next two conditions. Next two conditions will be if abc of array j minus array k bigger than b, then we make an exit, and only if abs of array I minus array k now return less than equal c, which makes the first two conditions were true, we increment our count using this arrange. We generally means kinda count equal count plus 1. Yeah, but we shorten this. And yeah, that's all. We can return our count. And let's submit this code and look how it works in Python. And it's efficient. Yep, slightly less than Java. And as we on Java wave, let's do JavaScript. Here we don't need kinda add system of type. We just write count using let. Then we will use let for n, which will equal array length. Then we precisely almost do the same than in Java. Nevertheless, it's two different language. Let I equal 0, I will be less than n minus 2, I increment, then for j, let j equal I plus 1, j will be less than n minus 1, j will be incremented, and we can check the first condition. So if here we also use the math, array I minus array j, and they are bigger than a, then we just write continue and skip it. That's the first condition untrue. Now for let k equal j plus 1, k will be less than and, so it continues to the length of the array, k increment. And now we will check again if array j minus array k bigger than b, because if it's true, then we can skip. And lastly, if array of I, then array k less than equal c. Finally, we can use count incremented. And let's return our count. And it's no typos, and let's submit. And let's vacuum. But generally, Java and, for example, JavaScript look quite similar. So yes, it's visible that they are from the C family syntax. If we compare to Python, where we skip naming and have slightly different description of length, where we put length first and then inside brackets we put array, and for in range we didn't declare I, we just write inside and we use range, and the first element that should be I is not declared by equal sign but declared by separation of comma, where j should be, for example, if it was Java, it will be in j equal I plus 1. But here we just write it as I plus 1. Yep, quite easily. Right, thank you for the attention. If you have any questions, feel free to leave them down below.